Was it tough? A tough cookie? You don't need to worry about, I won't do these ones, but they will be provided to you in the answer key that I will release. I didn't do that yet because I wanted you to kind of go over it. But then you have question 4, for example. That's when we get into the word problems. Okay, so if you have done this, or if this was a challenge to you, okay, I'm going to take some time to go over question 4 and on that handout. So have that handout next to you if you have it, because I'm going to refer to it a couple of times, okay? And I'm not going to write on the key, I'm going to write on the extra copy I have here. Okay, so let's see where we go. And sometimes I will organize the information in a chart. It may seem overwhelming, but it is actually easier for you to do, okay? Okay, so question 4, all right, follow along on your notes, write this down if you haven't done that. If you have, then it's time to check. A small clothing company will manufacture regular and deluxe shirts, right? So that right there should tell you the two variables that are at play. And if it doesn't click yet, keep reading, right? Production and profit information is summarized in the table. Available labor allows a maximum of 800 minutes. There's my restriction. That's what I'm after, right? The maximum of 400 minutes of cutting time and 600 minutes of sewing time, right? Each day. So there's a restriction there on the cutting time and the sewing time. I will maybe highlight that you have regular and deluxe shirts. That would be your X variable and your Y variable. Let me just focus a bit more. I think it's not focused. There you go. So your X and your Y variables, and you have a restriction on cutting time and restriction on the sewing time. Okay. Define the X and the Y of this problem. So X would be number of shirts, regular shirts, and Y would be number of deluxe shirts. Okay. Write a system of inequality to represent the constraints. So that's actually true. The inequalities are all part of the constraints. The implicit constraint is the x, y greater than or equal to 0, right? That's always there. It's almost like you're graphing a line along the horizontal and along the vertical, and you're shading everything to the left and below those lines. So you're eliminating all the 3 quadrants and leaving just the first quadrant. Okay, so this is the implicit constraint. We know that this is also, in this case, because it's number of shirts that we're talking about. And some of you might think, wait a minute, minutes, there are minutes mentioned there, but the actual variables are not minutes, right? Are number of shirts, number of deluxe and regular. That's what we're talking about. So we're talking about discrete data. X and Y are discrete, okay? Write a system of inequality to represent the constraints. So this was A. B, we're going to say that if you look at the chart, we have a restriction on the cutting time. And we know that it takes 20 minutes to make a regular shirt, 40 minutes to make a deluxe shirt. So that would simply be 20x plus 40y. We're talking cutting time here, right? The 20 and the 40 correspond to cutting time. So those are the coefficients we're going to use here. And that will be less than or equal to 800. There, it's all in minutes. Watch out for hours if they mention hours. So maximum 800 minutes of cutting. And then there's another inequality. It's the sewing time. So 30x takes 30 minutes to make a regular, 20 minutes to make a deluxe. And that has to be less than or equal to 600 minutes. Right? Maximum 600 minutes of sewing. Okay. Any other restrictions? Nope. They could have said that the company can only make or needs to make at least, 600 shirts, right? Then that would mean that you need to have an x plus y is greater than or equal to 600. So or 500, whatever it is. So you got to watch out. Don't read things into it, but be aware that that could be the case, right? So now we only have two restrictions. There's a restriction on cutting time and on sewing time. So what's up with the profit, right? Well, it's given, but there is nowhere is there a restriction on the profit mentioned. Nothing, right? It doesn't say they need to make at least, so many thousand or so many hundreds of dollars, nothing like that. So that is probably going to go towards the objective function, right? If you have information given and it's apparently not being used at first, this is where you're going to kind of say, okay, this is where the objective function comes in. However, there are instances where the objective function uses, these coefficients, and it is also part of an inequality. So you have to be ready for these coefficients to appear more than once. It could be part of your inequality, and it could also be part of your objective function. How do you know? Well, there's no restriction on your profit, so it won't be part of an inequality. Okay? None whatsoever. So C, write the objective function. That would be profit, right, is equal to $10 per regular shirt, and you make a $12 profit per deluxe shirt. Sorry, you can't see that. There you go. I was looking at the chart. So this is your objective function. So you got to make sure none of these, okay? It doesn't have any of that. It's just equal. Graph the system of inequalities. Label the corner points of your solution. How many of each type of shirt should the company make to maximize its profits? So right there, you know that there will be an ultimate solution to this problem, okay? So let's go ahead and graph this, and then we'll come up with the answer. I noticed that over the years on a test, when it comes to answering at the end, like the ultimate solution, students tend to not do it. They don't know what to do, and they just leave it, right? And that could cost you two marks, 3 marks. It depends on how many corner points we're talking about. And that would be too bad for you to lose that, okay? So let's graph this. So you've got 20x plus 40y. And I will try my best to give you enough room for you to do this, okay? So I'm just going to put them side by side, come up with the x and the y-intercept, and I actually will go through the whole process. X is equal to 40. Got 40, 0 there. And here it's 40y is equal to 800 divided by 40. Y is equal to 20, so it's 0, 20. I will rewrite it. And this is negative 1/2. I don't know if you see that, but solid. And we're going to shade above. And this next one here, x-intercept, y-intercept. And we have 30x is equal to 600. Divide everything by 30. X is equal to 20, so it's 20, 0. Here we have 20y is equal to 600. Y is equal to 30. That's 0, 30. And we have 20y is less than or equal to negative 30x plus 600 divided by 20. Y is negative 3 over 2x plus 30. We've got that. That is a solid line. And we're shading above here. Another reason why I want you to try a bunch of examples on your own is because you will notice that there are all kinds of different solution regions. You can't have seen them all really. So we're going to graph it here. Sorry, I'm going to scroll down a little bit if you're trailing with your notes. Some of you might have done this already, so you're just watching. This is number of regular shirts, number of deluxe, and I'm looking, I'm going to go 50 in each direction, so 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. And you've got 40, 0, 0, 20. And you've got 20, 0, 0, 30. And both of them are shade above, right? So we're just going to say that this one here is 20x plus 40y is less than or equal to 800. This one here is 30x plus 20y is less than or equal to 600. And one at a time, okay, so I'm going to shade this one above, right? And then you follow this other line, it's also above like that. Make sure you shade, right? So your solution region is here. We've got 4 corner points. I'm going to state them here. And we have discrete data, so we might have to round, okay? So we have 0, 20. Do not include the 30 here. That's outside already of the solution region. You've got 0, 0, of course. We've got 20, 0. And last but not least, we have the intersection there. So you've got to go use your calculator or do it by hand. And so we have I'm finding it quickly here. It's 10:15. Okay, so calculator here. We read, and we read. We just read it right off the graph. This one obviously would be worth a little bit more on a test or on a quiz. And why don't we run this through our objective function right away? P in this case would just be 12 times 20 because the x portion is gone. P here would just be 0. You can go ahead and just write down 0 because both of them are, it's not going to be in the running, right? 10 times 20 because it's 10x. And here P is 10 times 10 plus 20. No, sorry, 12. It's 12 for 12 times 15. And I'm running out of room, so I'm just going to do it below there. So here I have 240. Right, my profit is 240. 0 here. Here it's 200. And this one would be 100 plus 130. So that's 230, right? Sorry, no, that's not 130 because 12 times 10 is 120 plus, that's 180. Sorry, never mind. So it's 100 plus 180, that's 280. So this is the maximum here. Okay. Almost out of time. So a maximum there. So what we will say is a combination of 10 regular and 15 deluxe shirts will maximize profits. So when it's a word problem, make sure that at the end you tell me, because I want to know if you understand what that means, right? And there it is. Do questions 1, 2. So I assigned 1 to 6 yesterday. So if you haven't done that, then you need to do that today. And obviously 4 is already done for you. So I'm going to ask you to do all the way to 11. No, hold on. 1 to 8. 1 to 8. And then just go 10 to 11. Optimization. Worksheet. Okay. So tomorrow I will AC the folks coming through here, and what I will do is I will give you an AC to work at home, to work on at home, and then after that I will also have a Google form, which that's what we're going to spend the rest of tomorrow's class on. It's also going to be an AC. That one everybody will have to do that one, and I will get it's multiple choice and some short answer. So that's tomorrow. That's tomorrow's plan. So